All right, everyone, welcome back. Ready to dive in for another deep dive.
Absolutely, let's do it.
Today, we're tackling a topic that seems like a blast from the past, but is surprisingly relevant, the flat Earth theory.
Right. It's one of those things you kind of think is just an ancient idea, but it's having a real moment, and we're going to figure out why.
Exactly. And to help us unpack all this, we're turning to an article from Skeptoid, that website that's all about debunking myths and encouraging, well, good old-fashioned critical thinking.
Always a good thing.
So when most people think flat Earth, they probably picture, like, ancient civilizations who hadn't quite figured things out yet. But is that accurate?
It's a common misconception. The truth is, very few ancient societies, especially the ones with, sophisticated knowledge systems, actually believed in a flat Earth.
Really? So who are the folks back then that actually did have it figured out?
Well, I mean, think about the ancient Greeks, Pythagoras, Aristotle, Euclid. They all understood that the Earth was a sphere.
Wow. Okay, so we're talking way back centuries ago. But how did they know? Did they have, like, telescopes and satellites back then?
No, not quite, but they were incredibly observant, right? Take Eratosthenes, for example, a Greek scholar living in, get this, 240 BCE.
Okay, so that's, what, hundreds of years before Columbus discovered America?
Exactly. And yet, here's Eratosthenes not just believing, but actually calculating the Earth's circumference. And he got it shockingly accurate.
No way. That's incredible. I got to know, how did he pull that off without any of the tools we take for granted today?
He used a bit of clever deduction and a whole lot of sunshine. He compared the angles of shadows cast by the sun in two different cities at the exact same time.
Okay, I'm picturing it, but I don't quite see the connection to the Earth's shape yet.
So he noticed that the angles of the shadows were different, and he realized that difference was because of the Earth's curvature. Then, using a bit of geometry and knowing the distance between the two cities, he basically reverse-engineered the size of the Earth. Pretty ingenious, huh?
That's amazing. Talk about a testament to the power of, like, just paying attention and thinking things through.
Absolutely.
So if the ancients, or at least some of them, had this whole round Earth thing figured out way back when, where did this whole flat Earth resurgence come from? When did it pop back up?
Well, that's where things get interesting. It's not like there was this new scientific discovery that made people question the shape of the Earth. Instead, it was kind of a perfect storm of, you could say, social and ideological factors that came together in the mid-1800s.
Okay, so we're talking about a time of significant upheaval, right? The Industrial Revolution, new scientific discoveries challenging old ways of thinking. What else was going on that might have led to this?
You had a resurgence of biblical literalism, which is basically the idea of interpreting religious texts in a very strict word-for-word manner.
So less about scientific inquiry, more about taking religious texts literally.
Got it.
Yeah.
Precisely. And during this time, a rather interesting figure emerges, Samuel Rowbotham.
Samuel Rowbotham, the name rings a bell, but refresh my memory. What's his connection to all of this?
Rowbotham went by the pen name Parallax, which I gotta say is kinda ironic given what he believed.
A pen name. Sounds like he knew a thing or two about branding and grabbing attention, even back then.
Yeah.
Okay, so what made him so influential in this whole flat Earth revival?
He was really a true believer, completely convinced that the Earth was flat, and he was incredibly passionate about spreading that belief. He wrote a lot, traveled around giving lectures and engaging in debates, all to advocate for his flat Earth view.
So he was a real showman, a bit of a provocateur. I can see how that would draw people in. What kind of arguments was he making?
He based his ideas on what he called Zetetic Astronomy.
Zetetic Astronomy. That doesn't sound like any astronomy class I ever took. What is that exactly?
Basically, it's this idea that you should only trust your own sensory observations, what you can see with your own two eyes. So to him, if the Earth looks flat, well, it must be flat.
So he's basically throwing out centuries of scientific knowledge and observation in favor of what? Just looking around and trusting his gut.
That's pretty much it in a nutshell. And he outlines all these ideas in his book, Zetetic Astronomy, Earth Not a Globe, which he publishes in 1864. This book really becomes a cornerstone for the flat Earth movement. People are still referencing it today.
Wow, so this is where it starts to gain some real traction. I remember from our research, there's this whole saga with a canal in England, the Bedford Level experiment, right?
Ah, yes, the Bedford Level experiment. Now that's a story, definitely a turning point in the flat Earth saga, full of drama, flawed experiments, and it even involves a legal battle.
Okay, now you've got my attention. Legal battles. Over the Earth being flat. Let's hear it.
So picture this. It's the late 1800s, and John Hampton, a big-time flat earther, is so convinced he's right that he makes a public wager. He believes he can prove a 6-mile stretch of this canal, the Bedford level, has no curvature whatsoever.
Because, in his mind, if the canal has no curvature, then the Earth can't be a sphere.
Exactly. So he's basically putting his beliefs to the ultimate test.
High stakes indeed. Who ends up taking him up on this bet?
A surveyor named Alfred Wallace steps up to the challenge. They set up this whole experiment with a sight line across the canal. They're using a theodolite, which is this fancy instrument for measuring angles and elevation, all to see if they can detect any curvature.
Yeah. What happens?
Well, the results are in, and surprise, surprise, the Earth, in fact, curves.
So case closed, right?
If only it were that simple. Hampton, he was convinced that the experiment was rigged, that there is some kind of conspiracy to make it look like the Earth curves when it really doesn't.
Wow, so even in the face of what seems like pretty clear evidence, he doubles down on his beliefs. It makes you wonder if seeing isn't believing, what is?
It's a good question, and this is where I think the psychology of belief starts to come into play.
We'll come back to that in a bit, but first I want to know what happens next. The Bedford level experiment, that was the late 1800s, right?
Mm.
So how does this idea, this flat Earth theory, survive into the 20th century?
Well, you got to remember, ideas, they have a way of sticking around. And in the case of the flat Earth, it kind of gets woven into a larger tapestry of alternative beliefs.
Okay, so it's not just about the Earth's shape anymore. It's becoming something more.
Right. And this is where the story takes another interesting turn. In 1956, a fellow named Samuel Shenton comes along and founds the International Flat Earth Research Society.
Hold on, another Samuel. First, Rowbotham, now Shenton. Is there something about that name in flat Earths?
Maybe it's just a coincidence. But yeah, Samuel Shenton, he picks up the flat Earth torch, so to speak.
So tell me about this Shenton. Who was he? What was his deal?
Well, he was an English signwriter by trade, which I always found kind of ironic.
Ironic? How so?
Well, think about it. He's literally working with shapes and perspectives all day long, understanding how things look on a flat surface.
But promoting a theory that says the Earth itself is a flat surface.
I see what you mean. Definitely ironic. So what were his big ideas? How did his views on the flat Earth line up with, say, Rowbotham's? He was definitely in Rowbotham's camp when it came to relying on sensory observations and taking the Bible literally. He envisioned this circular Earth with a sort of dome over it, the North Pole in the center, Antarctica forming an icy wall around the edge.
Okay, so that classic flat Earth image you see, sometimes that's Shenton's influence.
Pretty much, yeah. But here's the thing, Shenton's doing all this during the dawn of the space age. We're talking satellites, space travel, images of Earth from space. How does he square that with his belief in a flat Earth?
Yeah, that's got to be a tough one to explain away.
You would think. But Shenton, he becomes a master of reinterpreting these events to fit within his flat Earth framework.
So instead of accepting the evidence, he's basically building a whole new reality where it all makes sense.
In a way, yeah, satellites. He claims they're just hovering over a flat Earth, pictures of a spherical Earth from space. He dismisses those as elaborate fakes, part of a grand conspiracy to deceive the public.
Wow, a conspiracy, huh? That seems like a whole other layer to this.
It's a theme that becomes increasingly central to the flat Earth movement as we move through the 20th century.
And what about Shenton's followers? Did they all buy into his interpretations of these major events?
It's hard to say for sure, but it seems like his views, especially his explanations for things like space travel and satellite imagery, they were even too out there for some members of the Flat Earth Society.
So even within the flat Earth community, there are degrees of belief.
Absolutely. It's not this monolithic group all thinking exactly alike. There's diversity of thought even within a movement as seemingly homogenous as the Flat Earth Society. But anyway, when Shenton passes away, the society kind of goes into a bit of a lull, but it doesn't completely disappear.
Of course not, because the internet's just around the corner.
Exactly. But before we get there, there's one more chapter in this saga, and it involves a couple from America who really push the Flat Earth movement in a new direction.
Okay, this is getting juicy. An American power couple taking on the reins of the flat Earth. Tell me more.
So, enter Charles and Marjorie Johnson. They become the new leaders of the Flat Earth Society in the 1970s, and they bring their own unique flavor to the movement.
Unique in what way? Did they have different ideas about the flat Earth itself, like a new model or something?
Not really. They stuck with that traditional, disc-shaped Earth model, but their focus shifted in an interesting way.
Oh, yes.
Well, under Shenton, there was still this attempt to engage with science, even if it was ultimately to reinterpret it to fit his worldview. But the Johnsons, they were much more focused on conspiracy theories, particularly those rooted in a very specific interpretation of Christian fundamentalism.
Okay, so they're really tapping into this idea that there's this hidden truth that's being kept from the masses, and they, the enlightened few, are the only ones who see the real picture.
Exactly. And to them, this wasn't just some intellectual curiosity, it was a matter of spiritual importance.
So they saw it as their mission to expose this supposed conspiracy, to wake people up to the truth.
Absolutely. And they weren't shy about pointing fingers. For them, anyone and everyone could be part of this conspiracy. Governments, scientists, even other flat Earth groups that didn't share their exact interpretation.
Wow, so they were even suspicious of other flat earthers. Talk about hardcore.
Hmm?
So they were really going all in on this idea of a grand conspiracy to hide the truth about the Earth's shape. What did they think was the motive behind all of this? Why go through all that trouble to deceive everyone?
To them, it all boiled down to a battle between good and evil, a cosmic struggle for the souls of humanity.
So it's not just about the Earth being flat anymore. It's about something much bigger, much more, well, apocalyptic.
Exactly. And this is where things start to get really interesting because their beliefs, they weren't just confined to this niche group anymore.
You're saying their ideas, their brand of flat earthism, it starts to spread.
It starts to seep into other areas of society. It starts to blend with other conspiracy theories, other forms of anti-establishment thinking. It's like this whole subculture starts to form.
And then, boom, the internet explodes onto the scene, creating a whole new world for ideas like this to flourish.
It was like the flat Earth movement was almost destined for the internet age.
Right. It's the perfect breeding ground for these kinds of alternative belief systems. Information, or at least what looks like information, is everywhere. People can easily connect with others who share their views, no matter how out there those views might be.
And you see that happening right away. Remember Daniel Shenton?
Wait, another Shannon. What are the odds?
No relation to Samuel, as far as I know. But anyway, in 2004, this Daniel Shenton, he creates an online forum called the FlatEarthSociety.org, and that becomes the new hub for the Flat Earth Society.
So it's the dawn of a new era for the Flat Earth movement, same basic idea, but now with a digital platform and a global reach. What changes with this shift online? What does the Flat Earth Society look like in the 21st century?
Well, it's a more decentralized movement now, right? Less about one charismatic leader like Rowbotham or Shenton dictating the terms, and more about like this collective sharing of ideas, videos, evidence, all trying to, chip away at the mainstream view.
So it's less about convincing people the Earth is flat and more about sowing seeds of doubt, encouraging people to question everything they thought they knew.
Exactly. It's like that old saying, a lie can travel halfway around the world while the truth is still putting on its shoes. Except in this case, it's not so much about outright lies, but about presenting misinformation, half-truths, cherry-picked data, all wrapped up in this package of like, hey, don't be a sheeple, think for yourself.
And unfortunately, it's a message that resonates with a lot of people.
It does, and you see this reflected in the kind of arguments that gain traction online. There are still those classic flat Earth talking points, the ones Rowbotham and the Shentons would recognize. But there's also this like blending of the flat Earth theory with other conspiracy theories, this whole matrix of distrust that extends to like, you name it, governments, scientists, the media.
It's almost like the flat Earth itself becomes this kind of gateway belief, a way for people to enter into this larger world of conspiracy and distrust.
It's a slippery slope for sure. And I think it speaks to something deeper going on in society today, this kind of, I don't know, this erosion of trust in institutions and experts, even in basic facts.
And in a world where information, both true and false, spreads at warp speed, that lack of trust can be incredibly dangerous.
It's more important than ever to be critical thinkers, right? To really examine the information we're consuming, to consider the sources, to be willing to change our minds when presented with new evidence.
To remember that just because something sounds plausible or confirms our existing biases doesn't make it true.
Exactly. And that, I think, is a good place to leave this deep dive. We started with a seemingly simple question. Is the Earth flat? And we ended up exploring this surprisingly long and complex history of belief, skepticism, and the enduring power of ideas, both true and false.
We've journeyed from ancient Greece to the internet age, encountered colorful characters, dramatic experiments, and some truly mind-bending theories.
And through it all, we've seen how important it is to approach the world with a healthy dose of curiosity, a willingness to question, and a commitment to seeking out reliable information.
So the next time you stumble upon something that seems a little off, a little too good to be true, or maybe even just plain strange, let it be a reminder to channel your inner skeptic, to ask questions, to dig a little deeper, and to never stop exploring the fascinating and undeniably spherical world we live in. Thanks for joining us on this deep dive, everyone. Until next time, keep those minds curious and those questions coming.